Welcome back to another episode of Python Programming from beginner to programmer. You can very visually see, right? Why am I in this bright orange red color? Yeah, today's topic has got to do with colors and images. And images will be the third section of our discussion on data visualization. So in our previous video segments, if you haven't seen them, just click on the related links. We started off with pandas set of functions and features for us to generate graphs and charts from data to plots, right? From data to plots. So we generated images and graphics using that set of library. And then we have higher level kind of visualization that is offered by another package called Seaborn. So that was our section 2. And today, right now, we're going to talk about section 3. How do we operate on images? How does a Python program see, process, generate, digest, and split and redo and modify and whatnot an image? All right, and when I talk about image, it is basically from any source. Um, Very importantly, of course, the source comes from graphs and charts generated from pandas and Seaborn. But today's discussion also allows us to process images coming from your mobile phone camera, your digital camera, your scanner, your email attachment pictures, your website pictures, and whatnot. So from all sources, so long as it is the familiar JPEG, PNG, and GIF, and all these familiar file formats, it's game, right? Whatever we learn today will be applicable. So let's get right into it. Now, our discussion today will involve some of these topics that are basically going from primary concepts to more detailed operations, as in allowing us to directly operate on the images. But first, we need to talk about the concepts. Through some of my teachings in classrooms and also in open seminars such as Stanford University's Code in Place, I learned that a lot of beginner students found image concepts very challenging. Uh, Perhaps it's the way we are now being oriented to see how computer sees images that is kind of a bit challenging because it's not our usual way, right? We look at images and then we somehow know what the image is talking about. But that's not how Python and computers in general see images. So how can we learn how a computer sees images, and perhaps that's why it becomes quite a challenging concept. But I hope through our discussion here, you should find it rather straightforward. So I'm going to give some sort of a no nonsense, direct to the point guidance. So you don't have to like read through the chapters and the books before you know what is image concept. So we just go cut right into it and observe the key points. Then we talk about files, file formats, and then we can convert the file types. And after that, once we are able to load images and save images and convert from various types, we are already very good. But we can only operate on wholesale, the image as is. We can convert the storage type, but we cannot yet operate on it, like dissect and change and do something interesting. So all those interesting stuff come at come from scale rotate onwards, right? So here we'll be just starting off, yeah, and then from scale rotate onwards, we'll do all kinds of somersaults and actions on the image, on the incoming image, enhance, filter, and all that. So I will kind of draw a slight distinction here because all these are basing the image materials on the content of the image. So we load the image and we take whatever ingredients, colors, and the pixels and everything there, and then sort of cut and paste and operate on it. We didn't generate, right? So something different from pandas where we generate the graphs from the data. So there's a sort of a creation process. All these are to slice and dice and massage and do something about the image content, maybe partially, maybe on a segment basis. But when it comes to drawing and texting onto the image, it is kind of on its own little subtopic because we are creating something, right? We're going to source text, maybe ask user type in your name, and we print the username onto the image. So that is going to be slightly different. So I just want you to take note because it's kind of subtle. Then finally, once you're able to do all these, we are then able to compose new images, kind of maybe even artistically. So that would be our agenda. And by then, using these together with our generated graphs and plots, we'll be very capable to perform a lot of these image operations. So let's begin with understanding image concepts correctly. When I talk about image concepts, what I'm talking about is how Python and the computer sees the image. All right, so it's not how we want to learn about the image. Uh, by and large, both kind of looks at the image for human and Python kind of similarly. All right, what is kind of different is in terms of the coordinate axis. So in high school mathematics, we learn graphs and charts where the center 0, 0 is in the middle, and kind of on the bottom left, if we look at the first quadrant, right? If we look at only at positive values, then 0, comma 0, the origin, sits on the bottom left. That's very familiar mathematical concepts that most of us here have been exposed to in our high school, teenage, growing up years. So the way we look at humans, look at image, will be just like that, right? That picture, that's all. We don't have a sense of uh, origin in a sense, and maybe if we really push it, we might say the center of the middle point of the picture is the origin, but that's not how Python sees it. All right, so all computer images in Python will be thought of, right, would be thought of, referenced as an image with a lot of cells. We call these indivisible cells pixels. All right, pixels. It's a bit like the data storage cell in pandas data frame. Yeah, in some sense it's quite similar. So each cell contains a pixel. We'll talk about what is a pixel, but for now it's a little bit like if you look closely at your television or your computer screen when it's brightly lit, you will see a little rectangular tiny little dot, or and then a lot of these dots are aligned in a two-dimensional grid like this. So each dot that we see will be a pixel. Okay, it's called a pixel. And each pixel is addressable. So in other words, you don't send a mail to it to write the address to it, but it is addressable in the sense that we can give a coordinate to pinpoint at any cell that we care to reference. Like this cell will have the address of x comma y. This is the main emphasis. Always refer to a pixel's address as x comma y. Now, many of you watching this might have already finished watching or learning about the data frame and pandas that we discussed earlier on in the previous video segments. And pandas respects the convention of row, comma, column. And I kept emphasizing that, right? So that we are not confused as to why we can't refer to that particular cell, that particular piece of data. Now, coming into image, it is customary and a sort of a main convention, both mathematically and computationally, to first address x, then y. So x comma y. That convention will carry through a lot throughout all the image processing functions. So if we would like to refer to this circled pixel here, then this pixel will be referenced as the address 6. All right, starting with 0, 6, comma 2. So horizontal first, comma vertical. Vertical is measured from bottom. From the top. All right, so horizontal I think is clear. I think it would be quite awkward if anyone were to propose 0 is from the right, 0, 1, 2, 3, right? So I think it's quite clear. It's always from left to right, left to right. But the y-axis can present a little bit of a challenge, especially to some of us here who sort of are very good at mathematics and graphs and charts. Then when you come over to pandas, you find that your picture is always inverted, and that's because the coordinates for y-axis in particular is inverted relative to our mathematical convention. So 0 on top, 0, 0 is the top left pixel, top left pixel, all right? So keep that in mind, and you should be steering uh, correctly in all directions and not get lost. Your North Star is on the top left. Top left. The origin is on the top left. Yeah. So these numbers 0, 1, 2, 3, and so on, they are not stored. They don't. There's no dot columns or dot index. If we borrow the pandas lingo a little bit, there is no storage of these. Therefore, the address such as 6 comma 2 here is implied. All right, the pixel is just known, just hardwired to be 6 comma 2. So just take it that way. All right, so that kind of deals with the big picture. When Python sees a picture, what is it to Python? So imagine this concept. Now, some of you who have a bit more exposure to the bits and bytes and memory storage will understand that actually in memory, all these pixels are kind of straightened up in a straight line and then stretches for very, very long memory space. And it's all one continuous string of bytes, actually. That's true. So internally means at the hardware wire level, it's one long big string. All right, but it's very difficult to think like that if we want to do anything higher level. So think of that one long big byte string that Python actually sees in the hardware as this two-dimensional table with top left as the origin. That would be the best way to imagine how pictures are stored.